Hi everyone, this is Daisy Merina, working as an assistant professor in the Department of Artificial Intelligence and Data Science in Wales Technology Dr. Nagaraj Dr. Sakatala Engineering College. Today I am going to take a video lecture on the topic outliers from the subjects foundations of data science and analytics. So first we will see about what is data science and analytics. So data science is nothing. It is a study of data that helps us to derive useful insight for business decision making. Okay, so data science is we are extracting the knowledge from the huge amount of data and getting deeper into the data sets. And analytics means nothing from the extracted amount of data. We are applying some computational techniques or statistical techniques for taking a decision. So as the foundation of the statistics, mathematics, and computer science, with the help of these three foundations, we are applying the data science and analytics in various industries like business, healthcare, finance, and education. So next we see about why we need to study data science. So data science provides various job vacancies in various sectors, including health sectors, technological base also. So many of the organizations rely on the data-driven decisions only because it reduces so many risks and it is able to improve their efficiency where they are lacking, and it is able to predict the future trends, what is going to happening in the future. So what are all the technological ways we have to improve ourselves. Then for this the essential skill we have to improve ourselves, we need to know about the artificial intelligence, machine learning, and big data fields. So one of the real time example we all know about the COVID-19, what are all the health scenarios and what are all the sequences we are facing. So with the help of the data analytics, it helps in the medical field to what are all the vaccine we have to give for the affected persons. So it is easy to give the vaccine distribution based on the guidance of the data analytic prediction. So now we will discuss about what is an outlier. So outlier, it is a data point that is far away from the rest of the data. That is, the outlier value is a value which is not included in the dataset what we are in need. So why? Because it does not follow any general pattern or no trend of the dataset will be present with the value. So for example, here is a dataset 20, 22, 23, 25, 24, 21, and 95. From viewing the data sets itself, we know the 95 is the highest value comparing to the remaining of the value. So 95 we can say easily it is an outlier because these values are very simple data sets. So by looking the data sets itself, we can easily identify which is the outlier value. If the data set is very large or if we are not able to view the data sets, how we have to identify the outliers? So many methods are using to identify the outliers. Why do outliers occur? But by mistake the outlier values are occurring. So one of the few errors are human errors. That is, while we are typing, by mistakenly we are typing 100 into 1000 or 1000 into 10,000, etc. So that is the human error or recording error, we can say it is. The next one is the instrument error. That is with the fault within the machine. Faulty machine recording abnormal values. So the fault is with the machine. The next type of error is natural variations. Some genuine reasons will be there. It is the tallest person, sudden stock crash will be there. So sudden variations will be there. The next one is the fraudulent or exceptional cases. Here, fraudulent means we can take it as the credit card fraud relations because so many fraudulent are occurring nowadays. So here, how the outlier value we can find means suddenly there will be a high transaction amount compared to the normal daily. We will be using the same credit card. Suddenly in a month, one day, high amount of will be transacted to some other amount. So by looking that itself, there is an outlier value. Someone is using our account, so we can easily identify the outliers. So now we will see about the effects of the outlier. So outliers are the extreme data points that will affect the values. Okay, affect the central tendency values. What is the central tendency means? Mean, median, mode, variance and standard deviation. It will heavily influence the mean and standard deviation value, but less effect on the median and mode, which are more resistant to the extreme values. So handling outliers requires careful considerations with common strategies including removal or cropping or data transformation, etc. So here it will affect the mean value. So mean value automatically there will be so many variations with the help of the outlier value. Median will not be much affected, and variance and standard deviation increase a lot due to the extreme values, and graph also error will be occurs with the help of the outliers. So example, the mark 40, 42, 41, 43 and 100, the mean value will be varied and median value will be more realistic. To identify the outliers, so many methods are followed. So one of the three methods are IQR, Z-score and box plot method. So IQR is nothing, it is interquartile range. Here we will take the lower bound values, upper bound values and we calculate the quarter values. So IQR formula will be used. Interquartile range is equal to quarter 3 minus quarter 1. Any value outside this will become the outlier value. And z-score method is also same. That is, we are using the z is equal to x minus mean by standard deviation. So if the value is greater than 3, then we will say the data set of is outlier. The values is mismatching and it is an outlier value. The next method is box plot method. So here we are using one graphical tool to show what are all the outlier values with the help of a dot method. Okay. So first we will see about the first detecting method, IQR, that is interquartile range. So interquartile range in statistics is used to measure variability by dividing a data set into quartiles. The data is sorted in the ascending order, then it will be divided into three equal parts. That is quarter 1, quarter 2 and quarter 3. So we will call it as the first quartile, second quartile, and then third quartile, respectively from the given data. So IQR is simply we are finding the difference between the third quartile and the first quartile, that is Q3 minus Q1. So what is the formula? IQR is equal to upper quartile minus lower quartile. That is we call it as upper bound minus lower bound values, that is Q3 minus Q1. With the help of this formula we will find the outlier value in the method of IQR. So next we will see about how to calculate the IQR value in step by step. Okay. So to calculate the IQR, we have to follow the step by step instructions. So initially step 1, sorting the data. Nothing. We are arranging the data set in the ascending order. Step 2, we need to find the median value. Median value is nothing. Quarter 2 value. The median is the middle value of the data set. If the number of the data point is odd, it is easy to find the median value, that is the middle value. If the count is even, what we need to do is we have to split the data into two halves, and from the two halves we will take the middle value. Then with the two values we will find the median. So next step 3, we are going to find Q1 and Q3. So split the data set into two halves based on the median value. So Q1 is the median value of the lower half and Q3 is the median of the upper half. It will not include the median of the entire data set, only to the lower half and the upper half. So next, so from the third step, we will find the value of the Q1 and Q3. Next step is the final step. We are going to calculate the interquartile range. So here we will subtract the Q1 value from Q3 value. That is IQR is equal to Q3 minus Q1. This gives the spread of the middle 50% of the data. By using these steps, we will find out the IQR value. One of the example we will see here. Okay, so the data set is the exam score of a 10th standard student. So what is the first step? We have to sort the data in the ascending order. So initially we are sorting the data. The first value is 64, 77, 78, 82, 85, 92 and 95. Second step, we are going to find the median value, that is quarter 2 value. So what is the quarter 2 value? Median value, the data set is even or odd? Check. 1, 2, 3, 4, 5, 6, 7. So it is an odd value, easy to find the middle point. What is the middle value? 82 is the middle value. So we find the value of Q2 is equal to 82. The next step is we are dividing the data into two halves, that is upper half and lower half, with the help of the median value. What is the median value? We know 82. So from the left side of the median value is considered as the lower half, and to the right of the median value is the upper half. Okay, so what are all the lower half values? 64, 77, 78, and the upper half value is 85, 92, 95. Now from these two values we are going to find the Q1 and Q3. So Q1 is the median of the lower half value and Q3 is the median of the upper half value. So from the given data set 64, 77 and 78, 77 is the Q1 value and 92 is the Q3 value. So it is easy to find the IQR value. What is the formula for IQR? IQR is equal to Q3 minus Q1. In the next step we will see that. So this is the diagrammatic representation of the IQR calculations. So from the given data set, 82 is the middle value. To the left is considered as the lower half, that is 64, 77, 78, and 83, 92, 95 is considered as the upper half. So in the lower half, 77 is the Q1 value, and in the upper half, 92 is the Q3 value. So what is the Q1 value? Q1 is 77, Q2 is 82, and Q3 is 92. Now we will calculate the IQR value in the formula. So IQR is equal to quarter 3 minus quarter 1 value. Quarter 3 value we already know that is 92 and quarter 1 value is 77. So subtracting these two values we are getting 15 as the IQR value for this data set. So how we will find outlier from this? If any value coming beyond the 50 will be considered as the outlier values. So with the help of the IQR, it is easy to find out the outlier values. The next we will see about the advantages and the limitations of the IQR. Advantages. So interquartile range offers the advantage of being resistant to outliers and suitable for the skewed data, but is limited because it ignores the extreme values and does not use all data points. So it making it less informative than the standard deviation for normally distributed data. So it will not affected by any extreme values. Then it is useful for skewed distribution, better than range, which is highly sensitive to extremes, that is resistance to the outliers. The limitations, it ignores the extreme values, that is ignores 50% of the data. Upper and lower extremes it will be ignored. Then it is very less informative for small data sets, not for the large data sets. It is very less for the small data sets. So Z-score. So what is Z-score? It is a statistical measurement of a score's relationship to the mean in a group of scores. So how we will define the Z-score? The Z-score is also called as the standard score. It measures how many standard deviations a data point is away from the mean. It standardizes the values by making different data sets comparable. Here we are using one formula, Z is equal to X minus mu by sigma. Here X denotes the data variables and mu denotes the mean of the data set and sigma denotes the standard deviation. Here we will see the interpretation of the Z-score. If the Z-score is equal to 0, then the value is equal to the mean. In case if the Z value is greater than 0, the value is above the mean. If the Z value is less than 0, that is a negative, the value is below the mean. If Z is equal to positive 2, the value is 2 standard deviations above mean. If Z is equal to minus 2, then value is 2 standard deviation below the mean. These are all the 5 z-score interpretation. Next, the general rule in the normal distributions. So about 68% of values lie between -1 and the +1, and 95% of the values lie between -2 and +2, and 99.7% of values lie between -3 and the +3. This is the general, these three, -1, +1, -2, +2, -3 and +3. These three are the general rule in normal distribution of the z-score, and the above five are the interpretation. If the value is equal to 0 or greater than 0, less than or 0, equal to +2 or -2, the interpretation is noted here. This is the z-score interpretation. Here an example we will see for the z-score. Here the mean value is 50, there is mu, then sigma is 10, and the question is find z-score for the data set of x is equal to 70. So we are applying the value z is equal to x minus mu by sigma. So x value we know, that is x value is 70, then new value is 50, then sigma value is 10. 70 minus 50 minus 10, that is 20 minus 10, that is equal to 2. Already we saw the interpretation. If z is equal to 2, then the standard deviation value is 2 and it is above the mean. So interpretation we have to write score of 70 is 2, so 2 is the standard deviation and it is above the mean. Now we'll see the applications of the z-score. So first one is the standardization. So it will convert the data to a common scale. It will standardize all the data into a common scale. Next application, it will be used for comparisons. So comparing scores across different test or distribution data sets. That it is used in comparisons also. The next one is the probability calculation. The z-tables give probability of a value occurred. With the help of the z-table, we will calculate the probability for a particular application. The next, it is easy to detect the outlier, identify values far from the mean, which is not related to the mean value. Then we are using this as the quality control. In manufacturing, we are using to detect the defective items. What are all the malfunction items with the help of the z-score values. If the z-score value is not related to the particular range, then the manufacturing object is it is having some defective nature. So these are all the applications of the z-score. So far we have discussed about the two methods. One is the z-score, the next one is the IQR method. These two are the methods to identify the outlier values. The third method is the box plot. So what is box plot? We will see here. A box plot is a data visualization that summarizes a data set into a distribution. So it will show the key features like the range, median and spread of the data, which is easy to understand the overall pattern. So it is an efficient way to spot patterns and identify outliers, that is data points that stand out from the rest due to their extreme values. In statistics, we will call it as a method for demonstrating graphically the locality through their quartile values. Now we will see the key components of a box plot. We will visually display 5 important numbers that summarizes the distribution of the data set. So a box plot will display 5 important numbers. What are all the numbers means? Maximum, minimum. Then we will call it as a third quartile, median, first quartile. So this three already we discussed in the interquartile range, that is first quartile, second quartile, third quartile. These three will come under the IQR range, already we discussed in the previous slide. Additionally, we are having the maximum data set value, then minimum data set value. So what are the 5 important numbers? Maximum, minimum, then first quartile, second quartile, third quartile. These are all the 5 key components of a box plot, which is used for summarizing the distribution of the data set. Minimum. What is the minimum value? The smallest value in the data set, that is excluding the outlier. We will not include the outliers values. After removing the outlier value, what is the smallest value in the data set? That is the minimum value. Then first quartile range, already we discussed in the IQR, the middle value of the lower half of the data set, simply we call it as the 25th percentage. The next median, that is the Q2 value, middle value of the data sets. That is, we are splitting the data set into two equal parts. So we will call it as a 50th percentage. The next key component is the third quartile, that is we call it as Q3, middle value of the upper half of the data set. So we will call it as the 75th percentile. The values will be little bit higher comparing to the Q1 and Q2. Then last one is the maximum. Here the largest value in the data set, again excluding the outliers, not including the outliers, excluding the outliers, which is the largest value, we will take it as the maximum value. So minimum, then Q1, Q2, Q3, then maximum value. These are all the 5 key number components of a box plot. So a box plot, in this diagram, it is clearly mentioned the three main parts. So what are all the main parts? IQR. IQR will contain Q1, Q2, Q3. Then the minimum value and the maximum value. This is a diagrammatic representation of the box plot. Beyond the minimum value, that is called as an outlier. And after the maximum also, this one is also known as the outliers. So in the previous diagram, we saw the two words whiskers, outliers and the box. So the box, what is representing means the box spans from the first quartile to the third quartile. That is IQR range will be represented in the box format. This box contains the middle 50% of the data with the line inside it representing the median Q2. Then whiskers. What is whiskers they are using here means the lines extending from the box called whiskers. It shows the range of the data. It will extend from Q1 to the minimum value and from Q3 to the maximum value. That is excluding the outliers. So these two lines denotes the whiskers. Then outliers. What is outliers? Already we saw the data points that fall outside the whiskers are considered as the outliers. These are marked separately and represent the values in higher or lower than the rest of the data. Here it is a sample box plot. It is a given value. The minimum value is 5. The maximum value is 8. In between, we are having the Q1, Q2, Q3 value. This is the sample box plot, how we are representing. So one box will be there, and from the box, two whiskers will be there. Then minimum and the maximum value. This is the diagrammatic representation of a box plot. Now we will see a summary of these three methods, that is IQR, Z-score, box plot method to identify the outlier values. So first we will see IQR values. It will identify outliers using the quartile values, that is Q1, Q2, Q3. The formula is IQR is equal to Q3 minus Q1. If the IQR value is 15 means what are all the values coming beyond the 15 values, it will be considered as the outlier values. The next one is the Z-score method. In previous slide, we saw so many interpretations of the Z-score method. If Z is equal to 0, what is the meaning? If Z is greater than 0, like that, we saw some of the interpretations of the Z-score and some general rules for the normal distributions. So it detects outliers based on a standard deviation. If the value is greater than 3, it will be considered as the unusual. The next one is the box plot method. Already we saw in the previous slide the 5 key components. It provides a visual representation. The outlier appear as points beyond the whiskers of the plot. So now we will see about SDG goals. This is Sustainable Development Goals. The Sustainable Development Goals are a set of 17 global objectives adopted by the United Nations in 2015. They aim to address poverty, inequality, health, education, environment, and peace by 2030. Together, they provide a blueprint for sustainable development that balances the economic growth, social inclusion, and environmental protection. How these SDG goals help in the outlier. These are all the 17 goals. The first one is the no poverty, second one zero hunger, third one is good health and well-being, fourth one is quality education, fifth one is gender equality, sixth one clean water and sanitation, seventh one affordable and clean energy, eighth one decent work and economic growth, ninth one industry, innovation and infrastructure, 10th one is reduced inequalities, 11th one sustainable cities and communities, 12th one is responsible consumption and production, 13th one climate action, 14th one life below water, 15th one life on land, 16th one peace and justice, 17th one partnerships for the goals. From the 17 goals, what are all the goals we can achieve with the help of the outliers? We will see in the next slide. Outliers and matched SDG goals. So SDG goal third is good health and well-being. In healthcare analytics, outliers may represent abnormal patient vitals, rare diseases, or unusual treatment responses. Detecting these outliers ensures early diagnosis, better medical decisions, and helps to reduce preventable death. Then outliers is matched with the goal SDG goal 6, that is clean water and sanitation. Outliers in water quality data, that is pH or contaminants, heavy metals, it can indicate pollution events or faulty sensors. With the help of the outliers values, we can improve the quality of the water. Then identifying them supports safe water monitoring for preventing health risk and ensuring sanitation standards. Out- Outlier is matched with the goal SDG 9, that is industry, innovation and infrastructure. In manufacturing and industrial analytics, outliers give the signal for the equipment failures, defects or any fault with the machines or any process anomalies, and detecting them enhances innovation in predictive maintenance and ensures infrastructure reliability. Outliers matched with the SDG goal 11, that is sustainable cities and communities. Outliers will be used in traffic, pollution or energy consumption data highlight for abnormal urban activities. It will managing these to help build smarter, safer and more sustainable cities with the help of the detecting the outlier values. Next, it is matched with the SDG goal 12, that is responsible consumption and production. Outliers in supply chain or production data may indicate wastage, fraud or inefficiency. Detecting them ensures resource efficiency, reduced waste and sustainable practices. Outlier is matched with the goal 13, that is climate action. So in climate data sets often contains the extreme values. So with the help of the outlier we can detect sudden changes in the weather conditions, so we can easily track the environmental threats and guide policy interventions. It is matched with the goal Life 14, life below water. Ocean and marine studies use outlier analysis to spot oil spills, coral bleaching events, or unusual marine risks. This supports conservation and sustainable use of marine resources. Then it is matched with the goal 15, also life on land. Outliers in biodiversity and forest data can signal endangered species decline or deforestation hotspots or wildfire anomalies. This helps to protect our ecosystem and it is used to promote our land to sustain for a long period. So as a conclusion, outlier reduction in data science is not just statistical. It plays a crucial role in achieving multiple standards sustainable development goals by identifying rare but critical events, whether in health, environment, industry, or sustainability. Managing outliers ensures accuracy, efficiency, and better decision making for global goals. Thank you.